All right. So, hey, we're here once again, to learn more data analysis with R. And I hope that, you've enjoyed all the sessions that we've had so far. We've learned a lot. Today, we're going to learn a lot more. So, I hope you guys are ready for what we're about to learn today. Okay, let's get started with, what I prepared for you today. Now, the reason why I always, start the live outside our studio is because I always want to make sure that I open our studio with you guys. Um, so let's do it. I am going to my project folder called Flight Analysis, and once again I double click on the project icon because I want to open up our studio from my project called Flight Analysis. I don't just want to open the script, I want to open the project itself. Okay, so now my project is open. I know that it's open because I have flight analysis opened up, written on the top right corner of my screen. So let me increase the font size a little bit for you guys. Okay, and now I am going to go ahead and open up the script we've been working on so far. So for that, I can click on Files here, and okay, not homework. It's flight analysis script.r. So this is my script, so I can just click on it, and there we are. Okay, we have the script opened up. Okay, as always, guys, whenever we start a new session like we're doing right now, we need to load our packages. Okay, so just run these 4 lines of code where we're opening up our packages. Here read dplyr and ggplot2, and we also need to load or import our data like we just did. And we know that the data has been imported when we can see the names of the 5 data sets right here in the environment. Okay. Now, just for fun, let me show you this quick trick. Of course, if you're using our studio, it's easy. You can actually look at this, look at your global environment, and if you see the names of your files there, that's fine. But there's actually a way to find out all the objects that have been created using code. So you can use the ls function. So I'm not going to do it in the script, but hopefully you guys can remember. So I'm doing in the console the ls function like this. ls all lowercase with parentheses. Alright, so let me run this, and it basically gives you the names of all the variables that have been created by you so far. Okay, so the list of everything you see in the global environment basically is going to show up here. Okay, so just a quick trick. Okay, so let's just go to the very bottom of our script now and continue. Alright, so the last thing that we did was to talk about the arrange function. That's the last function that we learned. And then we looked at more advanced data analysis by combining filter and arrange together. Okay. Alright, so what we're going to do now is we are going to learn a new function. So let's write a new comment, and it's going to be a subsection. So we've been doing it with the greater than symbol, and we're going to learn about the mutate function. Okay, the mutate function. And let's add a small description to it, and the description is going to be for creating new data. Okay, and we'll add the 4 dashes to it because we want it to be part of our we want to be part of our table of contents basically. Okay, so let's see the mutate function in action. So what does it do? Okay, in a few minutes I'm going to try and explain. Well, it does what I just said it does. Okay, it is used to create new data. Let's take a quick look at the flights database first. Okay, I'm going to decrease it a little bit because I would love for everything to show up. Okay, so I need to decrease. I think it is still, I think you guys can still see it like that. Okay, now I have everything. Okay, so this is the data that comes with the file that you downloaded. and that you imported. This is the data. Now you might actually want to create new data based on the data that is already there, okay? And whenever you want to create new data, well, the mutate function is what you want to use for that, okay? Oh, Leonard, thank you very much. I haven't done that. I haven't shared the live code. So there it is. I just posted it in the chat for you. Okay, so now let's assume that, as I was saying, we want to create new data, right? And what do I mean by that? You know, for example, the airtime variable here, okay, that airtime variable is actually in minutes. And remember, we said that this is how long all of these flights take, and it's in minutes, okay? And let's assume that for some reason, what we want to do is we want to convert it into hours. Well, the hour variable is new data because it's not already available in the flights data set. So we can assume that it is new data, right? So if you want to make some kinds of, you know, calculations like that, the mutate function is what you want to use. Okay, so let's do this. Number one, convert airtime in the flight data set in hours. Okay, so that's the first thing we're going to do. And it's also, the mutate function is inside the dplyr package. Okay, all right, and the way the mutate function is used is like filter and arrange. The first argument of the function is always the name of the data set that you're trying to use, and that's flights. Okay, and it was the same for filter, it was the same for arrange, if you remember. Okay, it's the same for mutate. Okay, next, what are we trying to do? We're trying to create a new data. Now, the next thing we need to do here is, okay, that new data is actually going to show up as a new column in our data set. So if we create a new column, what is the name of that new column? Now, what we're going to do now is we're going to use the same airtime name. So air_time, make sure that the spelling is exactly like it is in the original data set. So everything is lowercase, and air and time are separated with an underscore. Okay, now we're going to use the equal sign. Now this is different from filter. Inside filter we used equal. Equal means is equal to. But only one equal symbol means that we are trying to assign whatever we're going to write to the name airtime. Okay, so one equal symbol is assignment, two equal symbols is comparison, is equal to. Okay, I hope it makes sense. All right, so how are we going to calculate it? Well, to calculate it is going to be what is inside the airtime column, and we basically divide it by 60, right? Airtime divided by 60. Okay, so let me go over this code very quickly one more time. So what we're saying is that, okay, we're using the flights data set, then okay, whatever we're going to do is going to be assigned to the air_time name. That's going to be the name of our column. Okay, and inside that column we take the values that are in the already existing airtime and we divide it by 60. All right, so let me run this line of code now and let's check what happens. Aha, you see that the airtime variable here, okay, is still the same airtime variable, but now the values are different. Now, when I ran it last time, the first value was 227, okay, which is 2 hours and something, because 2 hours we know is 120 minutes, right? Oh, this is weird. I just divided by 60, right? So why is it 3 hours? 3 hours would be, that's weird. 60, oh, 220, sorry, I was thinking 120 in my mind for some reason. Oh yes, it's 3 hours and something, you know. 3 hours would be 180, right? And then 220 would be 3 hours something. Sorry, for some reason I saw 220 and I was thinking 120. Okay, yes, so 3 hours, 3.78 hours basically, you know, and you see that the data has changed. Okay, so that's what mutate does. And you see, the word in English to mutate means to transform what is already there, right? And that's what we did. We transforms the airtime data into hours. So that's a very powerful function because this is a very simple calculation, but you can actually use all sorts of computations or all sorts of transformations with the mutate function. Okay, so you can transform your data in every single way imaginable using some very complex functions. But of course, since I'm introducing it to introducing you to it, we're going to use simple calculations for now. Okay. Now, what if we wanted to keep the original airtime and then convert it, you know, and store the resulting data inside a new column without changing the original airtime? How would we go about it? Well, you can just copy and paste this line of code. Oh, no, sorry. You can copy and paste this line of code. So if you don't want to change the original data, it's very simple. The only thing you need to do is to provide a name for your column that does not already exist in the original data set. So if you provide here, if you provide a name that already exists in the data set, it's going to replace it. So even if I write month here, month, you know, which doesn't have anything to do with the airtime, it's actually going to replace the month column that you see here. Okay, so let's just give it another name. We're going to just, you know, to put it in context, we're going to call it airtime hours. Okay, so that we know that this airtime is in hours because we already know that the original one is in minutes. Okay, so let's run it. So now you see the original airtime is the same, and then we have a new variable. So we, you know, the flights data set has 14 columns, but now we have 15, and it's actually here. Now I'm pretty sure that you guys want to see it. Okay, so I'm going to minimize this. Okay, so that you guys can see airtime hours. So we have airtime and we have airtime hours. Okay, which is in hours. All right, so that's basically how to use it. All right. Okay, so let's have some more fun with the mutate function. We're going to do a few more things. Since we end the flights data set, let's try to do something else. We also have the distance, right? The distance. And I told you that the distance was in miles. But most of you, you know, watching are not living in the United States. Mary, welcome. I hope you're doing good. Okay. Most of you watching are not in the United States, so you are more used to kilometers instead of miles. And that's actually the same for me. I didn't grow up in the United States, so I'm actually still more used to kilometers than miles, right? So let's convert the distance values there in miles. Let's convert them into kilometers instead. Okay. Now for that we will need the conversion rate. Okay. Now this is a very good opportunity for me to tell you about what is called domain specific knowledge. Okay, DSK, domain specific knowledge. Now what I mean by that is this: you may be the best R programmer in the world, you may be the best R, you know, user or whatever in the world, but if you don't have knowledge in the field in which you're doing the data analysis, you won't be able to do a good job. So this is why, you know, for most of us here, we have different fields. Okay, Mary, that I just said hi to, you know, she has university level training in mathematics. That's what she did. And for other people, you're doing other things. Okay, so understanding the knowledge in your field is important, and you can now then use R to convert that knowledge that you have into code in order to get the results that you're looking for. Okay, so if you don't know the conversion between kilometers and miles, there's no way you can use R to do it, basically. Okay, so that's a very important parenthesis that I wanted to open. I'm going to pull up. Okay, so 1 mile in km, in kilometers, right? Okay, so that's the value here, 1.609344. Okay, so I am just going to copy it. Okay, and I'll go back to my code. I have so many things open here. All right, but let me write it first. Convert distance to kilometers. I think I should have written 2 hours here. Okay, convert distance to kilometers. All right, so there are 2 ways we could do it. Okay, you could change the distance column itself, or you could create a new variable. Let's do both because we are learning. Okay, and doing it the second time wouldn't really be difficult because you can copy and paste. Okay, so mutate flights, not airtime this time, is going to be distance is equal to the values in distance. Now all of these are in miles, so now we need to multiply by 1.609344. Okay, or 1.6, you know, if you don't want to be that specific. Okay. All right, so this is going to convert everything. All right, so let's take a look at distance now. So you see now we have, the first value was 1,400, and now this value is 2,253. Okay, which is exactly the distance of these flights in kilometers. All right. Okay, and while we're at it, let's just, you know, perform the same task by creating just a new column. All right, and this time the column is going to be called distance underscore km. We already know that the original distance is in miles, so we're just going to use the suffix km just for us to know that. And that new column that's going to be created, we have the same values, but they are in kilometers. All right, so I'm going to run this. Okay, I think my code is syncing. Okay, still syncing. Okay. All right, so now we have the distance in kilometers that you see there. Okay. Guys, that's a very powerful function because we can do so much, you know, depending on the data you have, we can definitely do so much. Also, I would love, Romina, would you please post, you know, the steps that you know you share with new people for the latency? How do you go about it? Will you please post it in the chat? I would love to know it because there are other people that I want to help as well. Thank you very much in advance. Okay, guys, so that's it for you know, the distance. There are other things that we can do, and actually what we're going to do right now is very important to the flights data set. Okay, we know that in the flights data set we have departure time and we also have scheduled departure time. Okay, so if there's a difference between departure time and scheduled departure time, then it means that there's some sort of delay. Okay, thank you very much, Romina. So it's in advanced, and then we can choose the latency there. Okay, thank you so much. Okay, so now we're going to create a new column in which we're going to have delay. And actually it's going to be very fun because, oh, okay, you want me to increase it. All right, Mary, I just did it. I made it bigger, but then I made it smaller again just because I wanted to see the whole data, but it's fine. We can actually look at it now using the view function. You're very welcome. Okay, so we're going to let me show the flights data. Okay, so we're going to create some new variables with delay. Okay, so how would we create a column for delay? Well, the delay is then the departure time minus the scheduled departure time. So it is very possible to do these kinds of computations with date time variables. Remember, this is the class of these columns, right? So if we subtract the scheduled departure time from the departure time, we're going to get the delay. But there's some more steps, you know, to take, which we're going to talk about. Okay, Romina is asking a question. I noticed that once I added the distance column, the airtime column went back to normal. Wait, okay. Oh, yes, we can. Okay, so it's a good question that Romina is asking. So she's asking, she said that, okay, when she, run the code for distance, she realized that the code for, for changing the airtime was not saved. And she's asking if there's a way to actually make this change more permanent. So it's actually a very good question, and I was going to talk about it at some point today, but let me go ahead and talk about it now. Well, whenever you perform all these tasks, it doesn't actually affect the original data. What happens is it creates a copy of the data and then performs the tasks on that copy and then displays the result. But the original flights dataset is not changed, which is actually very good. So if you want to save these variables, if you want to save these changes, you just need to save the changes into a variable, and that's what we're going to do. So if you want to change airtime and distance, you can do that and then save the result in maybe flights new. Okay, actually I'm going to have us do it later, and we're going to call it flights extended. Okay, but that's a very good question. Okay, but we're going to do it. Don't worry about that, Romina. I hope that this answered your question. Okay, so let's create, okay, compute delay metrics. Okay, so there'll be some measurement variables for delays. Okay, so the first one is departure delay. Okay, and the departure delay, we said, is the difference between departure time and scheduled departure time. So mutate, okay, flight, okay, and remember we need to write the name of the new column that we want to create. So that column is going to be called DEP delay, for departure delay, and then one equal sign. Okay, all right. Now we are going to use the names of these columns to make our computation. So it's going to be departure time minus scheduled departure time. Once again, make sure that this is exactly this is exactly written. What you write is exactly how the columns are spelled in the actual data set. Okay, now I'm pretty sure that we won't be able to see it in my console, but if you look at it at the very end here, you can see that there's departure delay that has been created. Okay, so we have all sorts of delays, and you have the class of that data, which is a class that we haven't really seen yet, DRTN, which stands for duration. Okay, so you have a time, you have another time, you look at the difference, so it basically gives you a duration. Now this class, you can actually do a lot with it, but we're not really going to go into that. What we want, because of the sort of fun analysis that we're going to do later, what we want is really, we want it in double class. Remember, double is for numeric values, and I think it would be better for us to have it in double time. So what we're going to do to this, guys, is, because this difference gives us a duration type data, let's convert it to numeric data. So I am going to wrap as.numeric. So as.numeric will convert into numeric data. Okay, we don't want duration. Okay, as.numeric, and then you wrap it with some parentheses. You wrap departure time minus scheduled departure time with some parentheses with as.numeric. All right, so I'm going to rerun this, and now we have departure delay as double. Okay, and I think it's better like that. And just for you guys to know, this is in seconds. All right, so we can't really see the values right now, but it's fine. We're going to use the view function to view these values. And let me actually go back to the question that Romina asked. Let me just save this. Okay, I'm going to call this flights 2. Okay, and I'm going to store this new data into flights 2, and it's going to be saved there. Okay, Romina, I hope you see what we're doing here. I'm running it, and I'm going to view, I'm going to view flight 2. Okay, remember this is capital V, and of course my code is not working anymore, my live code, but I'm going to make it again for you. But this is important, so Alright, so right now, guys, as you can see, we have the delays in seconds. And it's actually very convenient that we have it in seconds. You know, we have it in the smallest time unit. Of course, we have smaller time units than seconds, like milliseconds and stuff like that. But we have it in seconds so that we can use it and then convert it, you know, into all other types of time values that we want, like in minutes. And we're going to do it, by the way. We're going to do it. But we can see that it is in seconds right now. Okay, so let me change the live code. Yeah, I meant to look for a way to kind of circumvent this issue. You know, the issue that whenever I use the view function, I lose the live code. Hopefully I'm going to get something. So Mary's having an error. Object flights to not found. Did you use flights to inside mutate? If you did, then it's going to be a problem. If you loaded your data already, you're just storing it in. Okay, so if you wrote this code and you get your error after running the view line, it means that you haven't executed this line first. You know, you need to create flights to before using flights to. So if you did it, by running view, it means that you haven't run the mutate line first. That would be the problem. And Romina, you said the live code is still working. I didn't really add any new line of code, and that's why you saw the updated code. If I had added anything after that to line 181, for example, you wouldn't be able to see it. Okay, but I posted a new code for you guys. Okay. All right, so now we have it in seconds, and it's a numeric variable. Okay, and we just viewed it, which is basically, it's good to take a look at the data. Now, as you can see, some values are positive and other values are negative. Okay. Is it a minus sign? Yes, it's minus, yes. Oh, is it still too small? All right, so I made it slightly bigger. So it's a difference that we're looking for. Okay, difference between departure time and scheduled departure time. That would be your departure delay. Okay, so new link coming up in the chat. There you go. Okay, so Mary, you forgot to add the closing parenthesis. Okay, so hopefully you fix that issue now. Okay, so we just saw that the departure delay data is actually in seconds. Now, if we want to convert it in minutes, okay, which I think would make more sense in the context of flights, there was a 30-minute delay, or there was a 3-minute delay instead of there was a 120 seconds delay. This wouldn't make more sense. This wouldn't make sense. So let's basically continue our computation here. So after the closing parenthesis for as.numeric, so if you put your pointer on the right hand side of a parenthesis, the opening parenthesis should be highlighted, like you see here. You see, when I put it here, it highlights it. All right, so I now want to divide it by 60 because it's in seconds and I want it in minutes. Okay, and then I execute it one more time, and now we have our values in minutes. Okay, and okay, I was trying to say something earlier, and then I think I got distracted with the live code. But some values are positive and other values are negative for the departure delay. The positive values are actual delays. The negative values means that the flights actually took off earlier than the scheduled departure time, which I don't know why it would happen, maybe, but there are many flights like that actually when you look at the entire data. And we will actually do more analysis on it, okay? But there are many flights with negative delay, which means that the flights left early. Okay, so we were able to see it here. Okay, let's take another look at the flights data set. Okay, so we also have the arrival delay that we can calculate, right? The arrival delay. So a certain plane is scheduled to arrive at a certain time, then it arrives after that time, then you have arrival delay. So we can actually calculate it like this too. Uh, okay, now what I want to show you now is, instead of calculating all these things separately, and it all goes back to the problem that Romina pointed out. You use one mutate to calculate something, then you use another mutate to calculate something else. Like for example, let's write it down and then I'll continue explaining. Okay, compute delay metrics. Okay, so we can compute all sorts of delays here, but guys, let's just change this to compute departure delay. Departure delay. So that we can actually write another comment for compute arrival delay. Kinley, that's a good question. Do we have to rename our data set every time we add a new column? That's a very good question. You don't have to, but this is actually one personal philosophy that I have when it comes to doing data analysis. And I kind of alluded to it in the first few live streams actually. You can actually store it back inside the flights data set. If you store it back into the flights data set, then the old data that you have will be gone. The old flights will be gone, and the new data that you're calculating now is going to replace the old. Now, personally, I don't like that because data analysis should be transparent. Your data analysis process should be transparent. This is the reason why when we created the data folder in our project, we had a raw folder and a prepped folder. So whatever you start with, whatever the first data set you have is, I always like it to keep it, and whatever change you make to it, always save it into something else, so that you can see the code that takes you from point A to point B. That's the personal philosophy that I have for data analysis, and I think this is good practice as well, because if anyone asks you, okay, how did you get this, you can show them what it was at first and what it is now. So the reason why I'm using flights 2 is because I just didn't want to change the original flight. Okay, so that's how I do it, and because I'm teaching you, this is what I am going to teach you to do as well, and it is actually good practice, as I said. Okay, all right, so let's do arrival delay now, and for now let's call it flights 3. Okay, because we had something in flights 2 and we don't want to change flights 2. When you read your code later and you're trying to study, this might help you to go back to flights 2 and check what is in it. So let's just call it flights 3, mutate and flights, and now it's going to be arrival delay. So ARR_delay. Okay, it's going to be the same thing that we did. So first, it's arrival time minus scheduled arrival time. Okay, but remember, if you just leave it like that, it's going to be some sort of data that is called duration data, DRTN. But to make things easy, we just want to convert it into, numeric data. So as.numeric to convert it into numeric data. Okay, and now it's in seconds, right? So I'm sorry. Because I think it makes more sense to convert it into minutes, we're going to do it by dividing it by 60. Okay, and on your computer you can try to view it. Since I'm using a live code, I'm not going to try to view it. Okay. Oh, I said I was not going to try to view it, but I'm going to print it in the console at least, and you see arrival delay, and it's a double variable numeric, and we know how to handle these things. Okay. Okay, you know what? Now I am going to teach you how to, perform many different tasks like that at the same time. Actually, you do not need to keep calling mutate whenever there's a new data that you want to calculate, that you want to compute. Okay, you can actually use only one mutate, and perform all your computations inside that one mutate. So just like in filter and in arrange, in mutate as well, whenever there's something new that you try to compute, you can just add a comma and then compute it. Okay, and it makes basically our life easier, okay, to do it like that. All right, so compute, now this is where I'm going to add compute new several, compute many new variables. Okay, or let me say compute several delay metrics. Okay, delay metrics, delay measurements if you would like. Okay. Okay, now I'm not going to store it into anything this time. I'm just going to do a mutate, and the result is just going to show up in the console. It's not going to be saved anywhere. Okay, I'm just teaching you that. But there is one time, and this is going to be at the end of today, we're going to compute several things, and we're going to save it into a new file, or a new variable, I should say. I'm sorry. So mutate and flights. Okay, everything is going to be based on the flights data set, comma, like we know how to do. Now, for readability's sake, if we keep everything on one line, it's going to become a little messy. It's going to be hard to read the code. So this is a general rule in R. After every comma, it is possible to break a line. And if you break a line after a comma, you will see that RStudio will automatically indent your code so that you know that, okay, these new lines are under this one specific function. You'll see what I mean in a second. So you see, after typing comma here, you see where this took me? It didn't take me all the way to this, like below M. It took me here, So it will be easy for me to know that, okay, this is under mutate, and when you read your code later, it's going to be, nice like that. Okay, so let's start with departure delay. Okay, DEP. Actually, let's be a little lazy. Okay, select everything from departure delay all the way to 60. Don't take the parenthesis, because that parenthesis is the parenthesis that closes mutate, and we already have that closing parenthesis here. So you don't want to, you don't want to take it to. All right, so departure delay. So this line here is going to calculate our departure delay. So we can add another comma here, all right, because we want to calculate something new. All right, enter, because I want more readability. Arrival delay. Okay, like this, and I paste. Okay, so let me run this code, and now you see that we have departure delay that is added to our data, and arrival delay that is also added to our data. Okay, and you can actually compute as many columns as you want like that. So this also goes back a bit to what Kinley asked. So you see, Kinley, if you just need to add one more new variable, like one newer variable, after adding everything that you want to add. Okay, you just need one new variable, and then all these changes will be saved in that new variable. Okay, now there are a few other delayed metrics that we can calculate here. So one of our variables that we used actually earlier was air time. How much time in minutes, how much time in minutes we have for each flight, okay, or each flight lasted, if you want. But we could actually, it's going to be fun. We could actually calculate what is the scheduled air time. Okay, how long did was that flight scheduled to take? Because we had the scheduled departure time and the scheduled arrival time. So how long was it scheduled to last? Okay, each of these flights. Okay, so let's go ahead and add a comma here. Okay, and let's call it scheduled, SCHED. Oh, guys, this is American English, scheduled. I know that for you guys in Europe, because you are closer to Great Britain, you say scheduled, and this is how I used to pronounce the word for most of my life, because I learned English in a country where British English was spoken. Okay, All right, so scheduled air time, that's the name of our new variable, and this is going to be scheduled arrival time minus scheduled departure time. Okay, but once again, because these two columns here are in there are date time variables, so subtracting one from the other is going to give you some sort of data that is of the duration type, and we want it to be in numeric values. So that's why we're going to do the exact same thing as always, as.numeric, and then we're going to divide it by 60 like this. Okay. Now, okay, I'm giving you, I know some of you are copying my code, others are typing, so I'm giving you a few seconds. But there are, we can have a lot more fun with this. This is data analysis. We use the data we have to compute new data. That's fun, to me at least, okay? One thing that we can do is, for those of you who've used planes a lot in your life, whenever you have delays, when you're flying, you can hear the pilot usually say, okay, hello, ladies and gentlemen, we had a small delay because of, maybe they were, fueling the aircraft or something like that. But don't worry, we're going to try to make up some time, and we shouldn't really have that much of an arrival delay or something like that, okay? So of course the way to do that is to fly a little faster than was planned, okay, in order to make up the time, the departure delay, to make up some time, and we can try to find out if we had some time made up, okay, some time made up. How are we going to call this new column? I'm not sure why it's cutting me. Let me just do this. Okay, so let's say let's call it air time made up. Okay, now guys, one thing that you're going to realize with me as your teacher for data analysis is that guys, my name, the names that I use sometimes as variable names or as new column names in data sets like that are very long. I like to add as much context as I can whenever I'm trying to name something. Some people would just call it ATMU. It's great for them. I mean, if it works for you, that's perfectly fine. But hey, you know what? I don't want to come back to my code in 2 months and ask, man, what on earth is ATMU? I like to write everything or add at least some comments. Okay. All right. So what would then be the time made up? The time made up would be the actual airtime, okay, minus the scheduled airtime, which we calculated. All right. Or you can calculate the scheduled airtime minus the actual airtime, and this, depending on what you decide to put first. Mary, I don't really understand your question. Oh, air or R? Okay, no, it's airtime made up. So in the air, how much time did I make up? Due to the fact that they had some time of departure delay. So it's air actually, air time made up. Okay, arrival time made up. Hey, this makes sense too. So if you want to go with it, that's perfectly fine too. Okay, but my thinking was, okay, how much time was made up while flying? Okay, because maybe they flew a little faster or something like that. Okay, all right. So now let's do airtime, which is already in the data set, minus the scheduled airtime, which we calculated on the previous line. Now the reason why I think that this is a neat example is simply because I want to show you that if you create a variable inside Mutate, okay, that variable can actually be used downstream, so the code is going to know that, okay, this variable is already created, so now you can actually use it here, okay, which is, I think, pretty interesting, right? Okay, now second thing, airtime is originally in minutes, okay. The scheduled airtime here, you know, we converted it to minutes as well. So this is a valid thing to do. So we have minutes minus minutes, and all these are actually numbers, okay? So we know that they are minutes, but you know they are double variables, so we can just subtract, you know, without doing any sort of conversion in this case. All right, so this is what we're going to get there. All right, so if it took more time than was scheduled, then this value here is going to be positive. So a positive value would mean that you actually, you know, took more time that you were supposed to in the air. But a negative value would mean that, you know, that you made up some time. Ah, okay. So you know what? Maybe it's better to use scheduled airtime minus airtime, because what we are looking for is the time that is made up. So the positive values should be the made up time, okay, that you know that these pilots made, not the negative values. The positive value should. So let's do scheduled airtime minus airtime instead. So any positive value there would be the time that was made up, okay, and the negative values would be extra delays in the air, actually, basically. Okay, guys, there are, you know, a bunch of things that we can do, but I'm not going to do them because they're going to be part of your homework. Okay, if I do everything with you, then you won't have any homework to do. Okay, so let's run this. And guys, please, I encourage you to use view on your computer so that you can see these new variables there. But there are a bunch of things that we can still do there. But you see, scheduled airtime made up, arrival delay, departure delay, distance. You know, all these things, we computed 4 more columns, and these columns are there, okay? And of course, you can save this into a variable. But again, as I said, what we're going to do is we're going to, you know, I said we're going to do it today, but we're not going to do it today. We're going to do it next time, actually. Where, you know, in the flights data set, we're going to add many values, and we're going to save it into flights extended, and we're going to use flights extended later instead of using flights. Okay. The reason why we're using flights is because we're learning how to use mutate, right? So we need to keep using it over and over again. Okay, guys, so that's it for mutate. We did it on the flights data set. Let's use one other data set, you know, and use flights there, and use mutate on that. We know that we have 5 total, but let's do planes. Okay, I was actually going to give this to you as a homework. So if I write the code with you right now, there's not going to be any homework, basically. So okay, guys, what we're going to do now is, I think you already know how the mutate function works. This is basically how it works. So whatever I was going to do with flights, and there are other examples with weather, the weather data set is going to be in your homework, and with the airports data set too, is going to be in your homework, so that you can practice on your own. Okay, now let's take some time to learn something new, guys. We're going to learn a new way of coding. Actually, what we've been doing so far was we just learned about the filter function, the mutate function. But now that we have a third function for data analysis, well, we can do even more advanced analysis by combining filter, arrange, and mutate. So let's look at a few examples. I'm not sure we'll have time because I wanted to go over the pipe operator today. If we don't have enough time for it, we're just going to learn it next time. Okay, I was hoping to go over it, but yeah. All right, so guys, this is going to be a new subsection, and it's going to be filter plus arrange plus mutate. Guys, I'm telling you, the kind of things that you can do right now, it is really unbelievable. I use the mutate function a lot myself. You know, when I teach a class, at the end of the quarter, I need to compute grades, you know, like exams. I need to calculate the average of these exams here, and average of the quizzes, and combine them and apply the different weights. You know, if exams are 80% of the final grade, quizzes are 20% of the final grades, for example, you know, I use the mutate function to do all sorts of calculation. These things that we did right now, arrange cannot do it. what arrange does is what? Arrange, basically tells you what is the highest or what is the lowest. Filter doesn't do it. What filter does is filter takes some conditions and filters the entire data set according to these conditions. Filter cannot compute new data. Okay, mutate is what you need to do these kinds of tasks. Okay, so let's look at a few, maybe 2 or 3 examples with all 3 of them together. Okay, example number 1. Okay, and we all, of course, we had flights 2 here and we have flights 3. So Leonard just posted his code. Oh, when we use, Kinley, you asked a question, and I didn't see. When we use view flights, Kinley, of course the new columns are not going to show up. So Kinley is saying when we use view flights, the newly added columns are not displaying. Well, flights is the original data. So if you are viewing flights, it's the original data that is going to show. If you want the newly added columns, you need to save whatever data set you get after applying the mutate function. You need to save it into flights 2 or flights 3 or whatever, and view flights 2 or view flights 3. When you view flights, it's flights that's going to show up. I hope that you understand this explanation. It's just like what we did here. We calculated departure delay and we stored it inside flights 2, and then we viewed flights 2. Oops. Okay, guys, I think that we were disconnected for some time. Please, if you can hear me now, would you please say something in the chat? I think we were disconnected for some time. Can you please say something in the chat if you can hear me? Okay, all right, so I'm back then. All right, so Kinley, I hope that you understood the explanation that I gave. All right, so whatever you view is what's going to show up. So flights is not where the changed data set is. You have to save it into a new variable before you can view it. Leonard, you're saying that the airtime made up values for me are all negative large numbers. Okay, so let me take. Okay, I'm going to save it into flights 4. Okay, and yeah, guys, this is not something that I showed you. I'm going to use base R, but let me just do time made up. Yeah, this is in minutes. So yeah, it makes sense. Well, this would simply mean that this is what happened. Of course, it's weird. It's really weird that it's like that, because that would mean that there was a delay of more than 3 hours here for some reason. I'm not really sure why. Okay, I'm going to try to look a little more into the data, Leonard, and check what's happening here. But yeah, I mean, I would expect maybe 10 minutes or 15 minutes or something like that. If there was even more delay in the air, I wouldn't, expect these values to be that big. But you're perfectly right. So, again, this is good data analysis. You're looking at your data and you figure out that, what you've seen is not really in line with what you should expect in real life, right? So I'm going to look more into it and then get back to you guys on it next time we meet. Okay, yeah, I just wanted to look at this column, and that's why I wrote this code. Let me just leave it there, Let me just leave it there. Okay, so filter, arrange, mutate together. All right, so let's do this, guys. Let's do this. Okay. Which flight, not fight, flight, operated by American Airlines, okay, let's say which flight to Los Angeles, and that's LAX, operated by American Airlines, had the biggest okay, or let's say largest departure delay in the month of May. Which flight to Los Angeles operated by American Airlines had the largest departure delay in the month of May? Guys, when you look at this, you were not able to answer questions like that using R. But because you know filter, you know arrange, you know mutate, well, you can answer questions like that now. Okay? So this means that we have increased in our proficiency in data analysis. So guys, in this case, we will have to create some intermediate steps, and this is the last time we'll have to do it, because next time, I mean, looking at the time, we have about 20 more minutes. We'll need next time I'll teach you a way of coding which does not require you to calculate or to create too many intermediate variables. So let's start with the filtering process. So we want flights to LAX operated by American Airlines and in the month of May. So let's say AA LAX. Okay, so we'll filter flights, and we want the carrier to be American Airlines. We want the destination to be LAX. We also want the month to be 5. That's the first step. Okay, now the second step is actually to calculate the departure delays, because in the flights data set we don't have departure delays. I mean, you may say that, okay, we calculated departure delays in flights 2, line 179. You could say that, okay, let's just use flights 2, okay, and filter flights 2 here instead of flights. You would be totally right to say that. Okay, you would be totally right to say that. Okay, I'm just doing everything from scratch for this example and all the other upcoming examples, just because we are learning, okay? And just for the sake of teaching you, I'm going to do everything from scratch. So now I'm going to do AA LAX2, and now it's going to be mutate, and the filter data, that's what we're going to apply the mutate on, okay? The filter data. All right, and we said departure delay. Okay, so let's you can just copy and paste, the departure delay top here. You can just copy and paste it from here. I did everything on one line because we are just calculating one new, variable here. So you can break a line if you want, but you don't really have to. Okay. So I just calculated departure delay. All right, so I can see that it's here. It's the last column, okay? And the last step is now to rearrange. We want the largest, so we need to rearrange AA LAX2, okay, in descending order of that new data or that new column that we just created. Okay, it is numeric. So we can look at the order in descending order, okay, like this. All right, so the information of that flight was, again, we know it was operated by AA. It was a flight. Okay, guys, let me just decrease it very quickly. Mary, don't worry. I am going to increase it again for you. I just want to see. Oh yeah, we actually specify. So the origin was from JFK. And all the way to LAX, the airtime was 315 minutes, and so on and so forth. The departure delay is 174. Okay. All right, so let me go back to the size that everybody can see very well. Okay, so guys, you see how complex this is? Okay, and then it's not difficult. The thing is, you need to be able to identify what is being asked of you in the question, and use the tools that you know in order to, take care of each of these different components in the question, and then you get to the result. All right. Okay, I know some of you still want to see it. Okay, so let's look at 2 more examples. The next example would be, let's do something in, that again is still going to use everything. which flight operated by UA, okay, which is United Airlines, okay, in the first half of the year. All right. Which flight operated by UA in the first half of the year? Okay, let's add this. Which flight, okay, departing from LaGuardia and operated by UA in the first half of the year, okay, was the shortest. Okay, shortest. So here we're talking about time, okay, in hours. Okay, which flight departing from LaGuardia and operated by UA in the first half of the year was the shortest? Okay, in hours. Can add my question mark here. Okay, so again, we have several components. You just look at the components and you use the tools that you know to answer this question. Let's call this UA LGA. Okay, and we're going to start by filtering. Okay, we're filtering the flights data set. We want the origin to be LaGuardia because the flight is departing from LaGuardia. We also want the carrier to be UA. Okay, we want the carrier to be United Airlines. And it has to be in the first month of the year. So one of the first 6 months, right? And I hope you remember that. So that's month less than or equal to 6. Okay, so 6 is included. So month less than or equal to 6. And is that it? Which flight departing from LaGuardia and operated by UA in the first half of the year was the shortest in hours? Okay, so that's it, guys. So the filtering step is over. Okay, so we can save it. All right, next we need to right now airtime, which is the variable of interest here, airtime is in minutes. And we can't really do it, right? Because the question states in hours. So we need to convert airtime to hours and then use that converted value. It's going to be the same anyways. For those of you who know a bit of math, you know, dividing anything by 60 is a monotonic transformation. So the order is going to be kept, right? So UA LGA2. All right, so we're going to mutate UA LGA, the filtered data, and on that filtered data we are going to you know, let's just change airtime itself. You can create a new column, airtime hours, if you want, but let's, you know, just because we want to, you know, use different types of things, you know, let's just change airtime and not add a new variable. So it's going to be airtime divided by 60. Okay, now in UA LGA2, my airtime is in hours. And now let's arrange UA LGA2. And we're going to arrange it by airtime. And now that, you know, airtime has been changed in UA LGA2, well, in UA LGA2 here, the airtime right here is in hours. All right. So that flight was on the 21st of June. Okay, operated by UA, we said it. I wish I could see, you know, the destination, and the destination was CLE. I'm not really sure what CLE is. The distance was 419 miles. Okay. Is it Charlotte? No, Charlotte is CLT, I believe. I can check it very quickly on the internet. CLE airport code. Cleveland. Okay, Cleveland Hopkins International. Okay, there you are. I think, you know, switching to Google is, I think, the quickest thing. But I could have done it using code as well. You know, filter airport, I think it's called FAA, right? The codes here, yeah, that's FAA. So I could have done filter airport and then FAA equals CLE. All right, Cleveland Hopkins International, okay, with the additional information on it. All right, so last example for today, guys. All right, we're still on the flight data set, and again, the reason why we didn't use the other data sets today is because I want to include them in the homework. And there's actually not too much to do in these other data sets, except for the weather data set where there's a little bit to do, but most is done in the flight data set. Okay. All right. Now, what are we going to do here? Okay. So, which flight had the largest total delay? Okay, let's say which flight departing from Newark had the largest total delay? Okay, and we're just going to say that total delay is equal to departure delay plus arrival delay. Okay, let's just assume that this is how total delay is calculated. Okay, now before we do that, guys, I had it at the back of my mind and I wanted to tell you, let me tell you now before I forget. You don't have to start by filtering, you know, you don't have to. You could have started by mutating, you know, you could have started by creating on the big flights. Okay, for this, for example, you could have started by calculating departure delay on flights, and after calculating departure delay, the second step would then be filtering. That would still be valid. Okay, in the second example too, you could have started by converting airtime to hours and then, you know, added the filter. That would have worked as well. Now the reason why, okay, if you ever have to filter in the entire process, if you ever have to filter, it's always good practice to start by filtering, because when you filter and then you calculate new data later, it gives your computer less work. So the computer is going to make some computations on less values. Now, in this case, 300 and or so thousand values, that's pretty big. But in other cases, you could have millions of values. And you don't want your computer to be, you know, crunching all these numbers, especially because they're not even going to be needed for the task at hand, you know. So if you find yourself in a situation like that, filter first, you know, and if you filter first, it's going to help out your computer and the processing power. Okay, so all right, so let's start with the filtering here. So we're going to have Newark, that's EWR. Okay, so I'm going to call it EWR data or something like that. Okay, filter origin. Oh, sorry, we start with flights data set. Okay, and we want the origin to be Newark. We don't have too much to filter here. Okay, next we need to calculate total delay. So we have a few steps because we need departure delay, then we need arrival delay, then we need total delay. Okay. All right, so let me call it EWR data 2, mutate, and this is going to be on EWR data. And because we have several steps, I'm going to break a line here just for the sake of readability. Now we have departure delay and arrival delay. Guys, go ahead and copy and paste, you know. Go ahead and copy and paste instead of typing all this. And I included the comma here because we need that comma. Departure delay, arrival delay, and now total delay equals departure delay that we just calculated plus arrival delay that we just calculated. And now we have a new column called total delay. Okay, I can actually check it very quickly. total delay is actually part of my data set, as you can see, which is great. All right. And now I am going to arrange what the largest total delay. Okay, so EWR data to in descending order total delay. And it's some, I'm sure it's some insane number. Let me go ahead and I want to know that number actually. Oh, I didn't have to do it. I can actually make it smaller very quickly just to check it out. But hey, let me just do it very quickly. Data 3 total delay, and that's the arranged data. All right, so just look at the value on top, guys. Can you imagine the largest total delay in our data set is, you know, almost half a day, right? Because in a day we have 3,600 minutes. All right, so this is more than half a day actually. Okay, this is more than half a day. Oh, my bad. 3 divided by 2. Oh yeah, so this is less. Yeah, this is less. Almost half a day. Almost half a day. That's a pretty big delay. All right. So you know, when we start looking at data visualization, there's a very fun question that we're going to answer there. You know, actually we're going to visualize all delays, and we're going to see that one delay is at the peak, and we're going to go to Google to find out why that delay happened. Like we did last time, and Romina found some really interesting information for us. Thank you once again, Romina. And we're going to do that, and Google is going to let us know exactly why that delay was as high as it was. Okay, so we're going to do some fun things like that. All right, guys, I think this is a good time to stop. Please, if everything worked for you, would you please tell us in the chat that everything worked beautifully for you? And as always, I'm going to wait a little bit to see if some people have questions, but I like the fact that you ask your questions while we're doing this, so that, you know, we can address the issues right there and then keep going when, you know, once you understand what was wrong and everything. Okay, so did everything work for you guys, and did you learn something new? And there's going to be a new homework today, as I told you last time. The homework is going to be assigned every Tuesday now. If I don't, I think it's better because there's a bigger gap between Tuesday and Saturday, right? So it gives you a little more time to do the homework. Also, guys, I've seen that I saw that you guys, you know, have a lot of interactions in the homework questions channel on our Slack, which is really wonderful. So I've seen, you know, some help going on. So basically, I am not going to, you know, interact with you guys in the in the homework discussion. This is really for you guys to kind of, you know, discuss your codes and, you know, try to help each other. I am not going to you know, bother you guys in the homework discussions, but please help out one another. If you have some sort of code, post it there, you know, and try to help people if they have some problems. And what I do is I make the solutions and I post the solutions. And of course, you can always reach out to me whenever there's anything going on and I can help you. So some people have reached out to me on the private chat, you know, just in order to for me to help them with some specific questions, and you can definitely do that. So good stuff, guys. Okay, so my brother Leonard has a question. It worked for me. I have a question. Every day I have to save my daily scripts. How do I ensure that this is not repetitive rather than have one script? Oh, do you save your scripts in different files? Is it how you do it? If that's how you do it, then that's not what you're supposed to do, you know. Just keep that same script, and anytime you do work, you know, it's like muscle memory for me. I save it right away. You just click on this right here, and then it saves it for you, you know. Oh. Yeah, so it just is, and it saves it for you basically, you know. Or you can just do Ctrl+S. Online code didn't work for me, line 210. I'm not really sure why. Line 210 is part of a bigger chunk. So actually all this is going to be run together keenly. And if it didn't work for you, what error did you get? If you had an error, please post that error so that I'll know what was wrong. But line 210 only is not an individual line of code. But of course, because RStudio is smart enough, if you put your pointer on 210 and you run, it's actually going to run everything from 208 to 211. Okay, so but if you have an error, please post it in the chat, and I will try to figure out what went wrong with that. It couldn't view live code. Oh, okay. So did you try to refresh the live code? Because my live code is working perfectly. So refresh it so that you can see everything. You know, I'm looking at the live code right now, and it's working perfectly for me. Yeah. So yeah, thank you, Romina. So yeah, you just need to refresh, and it's going to work perfectly. Okay, I'm still looking at the chat. I'm not seeing any questions. Okay. Okay. All right. All right, Kinley. You're welcome. Okay, guys. So, well, I guess it worked for everybody. So I'm really glad to hear that you know the code worked for you. That's perfect. This is what I had for you today. Yeah, Mary, you're welcome. So I am going to post the homework a little later. I'm not done with it yet. You know, I was busy doing a few things, but the homework will be posted soon. In the meantime, I encourage you to, you know, if you have a little bit of time later, you know, to review what we did today. But that mutate function is very powerful. And as always, guys, you know, if you may want to come up with your own questions. You know, you have the data is there. It's on your computer. Leonard, you're welcome. You know, it's on your computer. So when you look at the Flash data set, you may want to come up. Okay, so I think I just... yeah, I think the live code is now interrupted. But you know, when you look at the Flash data set, you know, what kind of questions do you want to come up with? Just explore, you know, just use the tools that you have yourself and do the things that you want. Or if you have your own data, you know, maybe you are a student, or maybe you are you know, you work in a certain field and there's data that you have and you've been using Excel, or you've been using SAS or Stata to analyze it, and you would like to do it in R. Use the tools that we've learned so far, and then, you know, try your hands on the data yourself, you know. So that would be great. Romina, you're very welcome. It's really my pleasure. All right, guys. So it was my pleasure, you know, sharing this piece of knowledge with you today. And let's meet next time on Saturday, 2 p.m. Central Standard Time. And next time we're going to learn the pipe operator. By the way, Kinley asked the question, you know, here, and I had to use this operator here, and you guys didn't really know what it was. We're going to talk about it next time. It's a wonderful way of doing you know, coding without having to save intermediate steps every single time, save many variables. You know, it allows us to chain our operations together, and it's really great, and you'll see it, but we'll learn it next time. All right, guys, so I'm going to post the solutions of homework 2, okay, and homework 3 is going to be posted later today too. All right, guys, so I wish you all the best. You guys take care. God bless, and I'll see you around.